Okay, so we've taught you how to factor and solve by factoring, but that requires you to have a trinomial that's factorable or a quadratic that's factorable. We've taught you how to solve by square roots, but that kind of requires you to have a perfect square that you can take the square root of. So you've got to have some other methods because not every quadratic is going to cross that x-axis at a perfect little intersection. Not every quadratic is even going to be pretty decimals. Sometimes you might have an irrational answer, or you might have an answer that's just an ugly decimal. For those situations, we've got a couple more methods to teach you. The last one for this unit is going to be completing the square. And what this result revolves around is taking any quadratic and manipulating it still within the realm of algebraically legal things. So still doing things that we're allowed to do mathematically, but manipulating it to turn it into a perfect square trinomial so that we can take the square roots. All right, so our our learning target this time is just that we can solve quadratic equations by completing the square. Like I just said, a lot of times quadratic equations are not going to be perfect squares and can't easily be factored, and that's where we need some other method, the first of which is going to be completing the square. So what we're going to be doing is we're going to be taking some x squared and some bx, and we're going to be figuring out what's this little bit that needs to be added here in order to complete. Because when we square a number, we are kind of finding the area of a square with side lengths of that. So if you think about it visually, we're trying to figure out what's the size of the little bit that would need to be added here. So I'm going to show you the steps for this. The steps for completing the square seem really intense, but as with so many things in math, the more times you do it, the simpler it gets, and I promise it's not going to be as bad as you think it might be. So the steps are going to be, first, move the constant to the other side. This is weird and different because up to when we're factoring, we're trying to move everything over to one side. We're trying to get it set equal to 0. Here, you're going to want everything that has an x in it, every term with an x on one side, and you're going to want your constant on the other side. Then you're going to find the number that completes the square using this formula right here. My high school math teacher used to say, just cut the number in the middle in half and square it. And for some reason, that still sticks with me. I don't know why. It's not like catchy or anything, but that stays in my head. So you're going to take that b value, you're going to cut it in half, and then you're going to square it. You're going to add that value, whatever it ends up being, to both sides of your equation. That's just keeping things algebraic. If I do something to one side, I got to do it to the other side because we don't want to change the value of our equation at all. We want to keep it balanced. Once you've added to both sides, you're ready to factor. Now, here's something that's kind of nice. When you factor, because of the way you chose the number you added, it's going to factor into a perfect square trinomial every single time. It's going to factor to where you have x plus whatever that b over 2 is, squared, meaning you're going to have this, let me write that for you, meaning you're going to have x plus b over 2 times x plus b over 2, and it's going to be equal to some number, not 0, because you just added something to that other side, but it's going to look like this every single time. So that means the factoring should be really easy because whatever you got when you cut that b in half, that's going to be your number you see here. All right, then you are going to take the square root of each side. So this pulls in that method that you learned in 5-4. You're going to take the square root of each side and solve for x. So let me show you what that looks like. In example 1, remember I want to get all my x terms on one side, and then I need to get my constant off by itself. So I'm going to start by subtracting this 6x to move it away from that 4 so that my constant of 4 is by itself. So these aren't like terms, so I'm going to have x squared minus 6x, and then I'm going to have my 4. Now, I am looking for something that I can add right here that will turn this into a perfect square trinomial. Whatever I add there, I'm going to add over here as well. So to figure out what number needs to go in those boxes, I'm going to use this formula, this b over 2 squared. So I'm going to go off to my side work over here, and I'm going to say b over 2 squared. Well, my b value for this one is -6, so I'm going to put -6 over 2 squared. Well, I'm going to follow my order of operations, which means doing what's inside the parentheses first. Negative 6 divided by 2 is negative 3. And negative 3 squared is positive 9. So what I'm adding in both of these boxes is a positive 9 because it says add that number to both sides. So once you figure out what half of b squared is, you add that to both sides. That's going to be the number that completes this square because now I have a perfect square trinomial. If I factor this, I'm going to have x times x gets me x squared. And then I've got a positive here, but a negative here. That means I'm going to have negative in both. And the square root of 9, I'm going to put 3 and 3 because negative 3 plus negative 3 is negative 6. So that factors perfectly. Like I said, it's going to factor into the same two factors every single time. And the number you see here is going to be whatever that b value is divided by 2. So in this case, it's negative 3. It's the value that I saw right here. All right, on this side, I have 13. 4 plus 9 is 13. So I can write that as x minus 3 squared equals 13. And now I'm ready to take the square root. So I'm going to square root this side. I'm going to square root this side. I'm going to come over here because I don't have any more room. So x minus 3 squared, square root, and the square root of 13. Well, the square root of x minus 3 squared is just x minus 3. And over here, I'm going to have plus or minus the square root of 13. Then, the only thing I have left to do is get rid of this negative 3. So I'm going to add 3 to both sides. And my final answer is x equals 3 plus or minus the square root of 13. So it's an ugly answer, but that makes sense. That's why we couldn't factor this one. We had to go through extra means to get to an answer. It is still two answers because if you use your calculator and you say 3 plus the square root of 13, then it's going to tell you 3 plus the square root of 13. But if I hit my little, let me find it, there we go. If I hit this, it gives me positive 6.6. It's irrational because it goes on forever. Well, if I do 3 minus the square root of 13, then it's going to tell me this, and when I tell it to give me the estimate, it gives me a whole different number there. So those are the two roots, those are the two places where this parabola would cross the x-axis. All right, I'm going to really quickly do another example because you may see one that has a coefficient of a here in front of this x squared. So completing the square as a method really only works well when you have a 1 or a no coefficient there in front of that x squared or an understood 1. So check to see if you can factor out a GCF. This one, I can factor out a 4. That's going to leave me with x squared plus 8x plus 4 equals 0. And now I can divide by 4 on both sides. The reason I'm going to divide by this 4 is because here that cancels and leaves me with just a simple x squared plus 8x plus 4. Over here, 0 divided by 4 is 0, so there's nothing else I have to deal with. Now I can start following my steps. So the first step was move the constant to the other side, which in this case means I am going to subtract 4 from both sides. That gives me x squared plus 8x equals negative 4. Oops, I don't know why I wrote that like that. There we go. X squared plus 8x, I'm going to leave myself a little space here to add my box because I know I'm going to be adding something there, equals negative 4 plus something. All right, now I have to figure out what that number is going to be that I need to add to complete the square. So I'm going to say b over 2 squared. Well, my b value this time is 8, so 8 over 2 squared is 4 squared, which is 16. So I am going to add 16 to both sides, which gives me x squared. Well, let's go ahead and factor then. My next step is to factor. So when I factor it, it is going to be every single time you're going to have x plus whatever that half of your b is, so in this case 4, squared. If you want to check to make sure that works, x plus 4 times x plus 4, x times x is x squared, x times 4 is 4x. Across the bottom, 4 times x is 4x, and 4 times 4 is 16. So I've got x squared plus 8x plus 16, which is what I was expecting. And then over here, negative 4 plus 16 is 12. Now the next step, we've factored. Now we've got take the square root of each side. So when I take the square root, I'm going to take the square root here and here. That leaves me with just x plus 4, because the square root and the square cancel. The square root of 12 simplifies to 2 root 3 plus or minus. Don't forget your plus or minus. And now I'm ready for my final step, which is to solve. So now I can subtract this 4 from both sides, and I get x equals, it's better to put your minus 4 in front, because otherwise you guys, and myself included, get sloppy with our radicals, and it's hard to see where that radical ends and whether that minus 4 is under the radical or not. So you should put x equals negative 4 plus or minus 2 root 3. So it's not wrong if you put plus or minus 2 root 3 minus 4. It's just better form to write it this way. All right, then again, that is your two solutions. If we asked for a decimal solution, then you would go through and in your calculator you would put negative 4 plus 2 root 3 and get an estimate, and then you would put negative 4 minus 2 root 3 and get an estimate. All right, your U-tries are right here beside me, so go ahead and attempt those. Use scratch paper. I know I didn't give you a ton of space on this one. I apologize. And then it's time to start getting ready for your test once this one's done. So good luck, and we'll see you in the next unit.